Hey everyone, it's Wilman here. I'm just going to make a short video to talk about what we're going to do in pre-algebra this week. So this week in pre-algebra, we are going to find the volume of solids or of three-dimensional shapes. So if you remember 2 weeks ago, we did the area of two-dimensional shapes like squares, circles, triangles, etc. Last week we did surface area of three-dimensional shapes like we did cylinders, we did prisms or kind of like a boxy shape like this, we did pyramids, and essentially surface area talks about the amount of space that is needed to cover the outside. Well, this week we're going to talk about something called volume, which can be defined as the space enclosed, or if you just want to think the space inside, occupied by an object. So all I really want to know is, if I give you a shape, I want to know how much space is there inside of that shape. So the difference between volume is that you're actually considering the whole entire inside part of the shape, not actually just talking about the outside like surface area. So we're going to kind of run this video like we did last week. We're going to go over a handful of examples together because based on what shape you're given, that kind of depends on what your formula for volume is going to be. Okay, so let's start with, I'm going to call it a cube. So kind of like a dice. Let's say this is my cube. And when I'm doing these drawings, they're not going to be perfect. And you're going to have to kind of imagine what this shape looks like if it was sitting on a table in front of you. Okay? So this is my attempt at a cube. What is a cube? It has all three sides the same length. So all of these little square sides are the exact same. So to find the volume of a cube, all you need to do is take the side length and cube it, or take the side length and take it times 3, or take it times itself 2 more times, excuse me. So let's say in my example, the side length of this cube was 2. So 2 tall, 2 is the base, and 2 deep, okay? So all you would need to do is take 2 to the third power, which would give you 8. 8 units. If you remember from last week, surface area always dealt with our label squared. But when you talk about volume, you need to put a little 3 for cubed. And why does it have to be cubed? Well, because we're actually talking about a three-dimensional shape, like a cube. It's three-dimensional, so we need to have our units cubed. Volume is always cubed, surface area is squared, because that's area, okay? And I guess another way you could do the volume of a cube, this will relate to the next one. You could just do base, the big base, area of the base, times the height. Whichever one of these you want to do, that's totally fine by me. So what do I mean by the B? I mean the area of the base. So this blue here is the base. That's like a square, okay? What's the area of that square? Well, it's actually just base times height. So it's going to be 2 times 2, which is 4. So I could just write my formula 4 times my height. My height is 2. And we know that 4 times 2 will give us that 8 units cubed also, okay? So 2 ways you can do cubes. Same answer both times, okay? All right. Related to cubes, or those boxes, you're going to have prisms, okay? So prisms, an easy way to remember this, they're essentially just like box shapes, okay? Boxy shapes. So here's an example of a rectangular prism, because it has a rectangular base. It looks kind of like our cube, but it has longer sides, okay? So this could be like a box you get from the UPS man if you get a package or something like that, okay? I think that looks okay. Okay, let's say I have these numbers. Let's say that's a 5, that's a 3, and it's a 2, okay? The way you're going to do this is by taking the base, again, times the height. So again, what's the base? The base is going to be this bottom rectangle. So 5 times 3, which is 15, times my height of 2, which will give me 30 units cubed. Okay? So again, very similar to our cube if you would use the second formula. Very similar idea. And the reason why I think these formulas kind of make sense is because if you look at this example right here, that box, what is that box or prism made up of? What do you have to stack on one another in order to get that shape? Well, if you think about it, all you need to do is take this base, this bottom of 15, and all you need to do is keep stacking these on top of one another until you get the desired height of 2 inches. So all you're doing is stacking a bunch of these boxes on top of one another to get that overall shape. And the reason why you get the 30 is because you have to take it times that height of 2, okay? All you're doing is stacking the bases. That's why that formula makes sense. Okay, there's one more variation in this. I guess there's a lot more, but we're only going to focus on one more. Let's say you have, I'm going to call it a triangular prism, okay? So it's going to be kind of like the ones above. Bear with me on the drawing here. It's essentially going to be a prism like the one above, but instead of having a base that's a rectangle, it's actually going to have a base that's a triangle, okay? So let's say it has a height of 6 inches. Let's say this top number is 4 inches, and let's say the height is, let's say that's a 2 inches, okay? I want to know the volume. So again, the volume is simply going to be the base times the height. So what's our base? Our base is the blue triangles. We want to stack a bunch of triangles on top of each other, okay? So how do you find the area of a triangle? You need to take half of that base times the height. So you need to take half of 4 times 2. That'll give you the triangle. And then you need to take that times the height of 6. Okay? So after we do some calculations here, half times 4 is 2, 2 times 2 is 4, and that guy times 6 will give us 24 inches cubed. So we found the volume of that triangular prism. The only difference between the triangular one and the rectangular one is that the base in the rectangular one was a rectangle. You just need to take that 5 times 3. But then in the triangular one, you need to find the area of that triangle, which would be base times height divided by 2. But the same general big formula, okay? So for sure, I would say this would be a good thing that we should know. And so would this one be. Base times height. That big B meaning the big base, okay? All right, let's keep moving. I'm just going to erase a couple of these guys. Okay, let's see, what shape do we want to do next? We got that one, got that one. Ooh, let's do some good ones. Let's do pyramids and cones. The reason why we're doing these two together is because they have similar formulas for volume, okay? So a pyramid, what do I mean by this? I mean something, and you're going to have to kind of bear with me on this one. Let's see if I can get this guy to look decent. I want to erase that part. Okay, so this is kind of my three-dimensional drawing of a pyramid, okay? I know that's not the coolest thing. If you would look at it, if you would set it on a table and you'd look at it, it would kind of look like this, straight on, okay? It's a triangle, triangular sides with a square bottom. Let me think about another way I can draw this, because that doesn't look super great. What about this? That looks a little better. Let's go with that guy. Okay. So the volume for a pyramid is close to the prism, but you have to do one additional thing. You need to take 1/3 of the base times the height, okay? And the reason why you got to do 1/3 is because if you forgot that 1/3, it would be the same as a rectangular prism. And you can see based on our picture, those are not the same, okay? So let's say my base, let's say I had these numbers. I'm going to put a 7 feet here, a 7 feet over here, and for this part, from the tip up here down to the middle, I'm going to say that's 8 feet. Okay. If we had to find the volume, we would do this. 1/3 the base, so the base would refer to that bottom square, okay? So it'd be 7 times 7, which is 49, times the height of 8, okay? So if we take 1/3 times 49, we're going to get 16 1/3, or 16.33 repeating. And if we take that times our 8, we're going to get roughly 130.7 feet cubed, okay? So, you're probably asking yourself, Mr. Willman, what is a pyramid? A pyramid basically just has a polygon base, so like a square or a triangular base with triangular sides. And we've all seen pictures of like the Egyptian pyramids. Each one of these sides right here in purple, each one of these sides is actually a triangle shape, okay? So a pyramid has a base, doesn't matter what the shape is, but it has triangular sides. If you see the triangular sides, that's when you have to use the formula here with the 1/3. Okay, let's move to cones. So cones are actually going to be very similar. This one's going to be a little easier to draw. Here's my ice cream cone, okay? Just made myself hungry for ice cream. Maybe I'll add a little bit of texture to my waffle cone, make me even more hungry. There we go. Okay, let's say my cone, it's a circle on top here. This is a circle, circular shape. Let's say I have a radius of 5 meters, let's do centimeters, and a height from the top all the way to the bottom here. Let's say that's 12 centimeters. I want to find the volume, how much space is inside of that cone, okay? So the formula for this one, as I kind of alluded to, it's similar to the pyramid. It's 1/3 base times height, okay? And the reason why I said it's similar but not the same, you'll see why here. Okay, we got to do 1/3 of the base. Before you write something down, you have to realize our base in this example is not a box or a triangle. This is our base. Our base is actually a circle, okay? What's the area of a circle? Well, I'm hoping we remember it's pi radius squared. So for the area of my base, I'm going to write pi. My radius is 5 squared times my height of 12. Okay? So we're going to do 1/3 of, I'm going to take 5 squared, which is 25. I'm going to take 25 times 3.14, because that's essentially what pi is. So I'm going to have 78.5. And you can use the symbol pi, but I'm just going to use 3.14, okay? And then we got to take that times 12. So 1/3 times 78.5 times 12. I'm hoping that Mr. Willman did this correctly. I got 314 centimeters cubed. So let me just double check here. I took the area of the base, so pi r squared. R was 5, so pi times 25, yep. Times the height of 12, yep. Times 1/3. That should be good, okay? So the next two formulas, the pyramids and the cones, those are going to be important for us, okay? We only have a couple more to go, okay? So we are 16 minutes into the video. I know these last couple have been long, but I feel like they've been the appropriate length for what we're talking about. We're almost done. If you want to pause, though, feel free. All right, here we go. Let's see. We got to talk about a couple more. So we did prisms, pyramids, cones. That's going to leave us, I think, with the last two big ones. Cylinders and the weird one, spheres. So the cylinder one I'm hoping isn't too hard for me to draw. A cylinder is essentially just like a can shape, okay? Like you buy canned food at the grocery store. That's what a cylinder is, okay? So for a cylinder, I'm going to say that it's 10 inches tall and it has a diameter of 8 inches. Okay. To find the volume of a cylinder, again, I sound like a broken record. All we need to do is take the base times the height. So why is it the area of the base times the height? Well, if you think about it, this cylinder shape, look at the bottom and look at the top. It's the same thickness. All a cylinder really is a bunch of circles stacked on one another in order to create the given height. All of these circles, all of these slices are the exact same. So all you need to do is find the area of one of those circles and take it times the total height. So my base, what's the base? It's a circle. I need to take pi radius squared. I didn't give you the radius. I gave you the diameter. I gave you the distance from this side to the other side. So we know the radius is half of 8. So it's 4. So pi times 4 squared times my height of 10. That's going to give me my volume. So if you take pi times, let's see, 4 squared is 16. If you take 16 times 3.14, you're going to get 50.24 times 10. That's going to equal 502.4 inches cubed. So notice again, a lot of these formulas are just the area of the base times the height. As long as you can determine what shape the base is, that's going to make a lot of these problems seamlessly kind of act the same and be a little easier, okay? So 502.4 inches cubed would be a good answer for this one. All right, one more. Spheres. A sphere is kind of like, I think the easiest way to imagine it's just like a basketball, okay? So it's like that. Mr. Willman's awesome drawing. So this is probably the weirdest formula out of all of them, I would say. This is going to be my basketball shape. I'm going to say that this shape has a diameter of 12 inches. That's all I need. The volume of a sphere is 4/3 pi r cubed. That's it. So the only thing you need to know is the radius. So if we take 4/3 pi, my radius is the distance from one end to the middle. So from here to here, well, I know this whole thing is 12, so from here to here has to be 6. So I'm going to put a 6 in the formula and cube it. So 4/3 pi times, that should be a 216, I believe. Let's take 3.14 times 216. Gonna get this. $678.24. And we take that times the fraction 4/3. We're gonna get, wow, big number, 904.32 inches cubed. Wow. So this sphere, or this basketball, occupies 904.32 cubed inches. Okay? Cubic inches, I should say. So we talked about prisms, like boxy shapes. We talked about a triangular prism. We talked about cylinders, like cans. We talked about basketball shapes, like spheres. We talked about cones, and we talked about pyramids. So I think that's all we need to be successful this week. Again, here's the formulas for spheres. Here's the formula for a cylinder. Remember that the base of a cylinder is a circle. Okay. So after watching this video, take a look at the worksheet that we have on our Google site. You can check your answers with the key that we will provide. And if you have any questions, as always, feel free to email your teacher. All right, thanks for watching, guys. See you later.